Hi everyone, my name is Ang and welcome to my presentation for the Introduction to Material Science class. Today I want to present about polylactic acid or PLA and discuss about its properties and application. So here's the overview of my presentation, including the introduction of PLA, its properties, its manufacturing process, PLA application, some challenges, and my final thoughts regarding this material. So let's start it with the introduction. Firstly, I want to talk about the motivation. So plastics are known for its convenience and huge application in packaging industry. However, the global polymers total production has reached a total of 9 billion tons, but only 9 to 10% of them is recycled and reused. A small amount is incinerated, but most of them accumulated in the environment, mostly in the ocean. This has resulted in serious problems such as environmental contamination or toxicity to the ecosystem and human health. Therefore, scientists are motivated to investigate alternatives for conventional plastics. And polylactic acid, or PLA, is one of the eco-friendly, biodegradable, and biocompatible materials produced from renewable biomass sources, such as cornstarch or sugarcane. It is a promising substitute to petroleum-based polymers, such as polyethylene or polypropylene. Next, I would like to talk about different properties of PLA, including physical, optical, and mechanical properties. So, as you can see on my presentation, is the detailed properties listed for the poly-L-lactic acid film. So, but I would take a few important values to talk about. So, firstly, PLA is known for its lightness and transparency with a low density and high visible light transmission value. It has high tensile strength, Young's modulus, and flexural modulus, but it has a low heat deflection temperature, which limits its usage in thermally processed packages, which can lead to deformation at high temperatures. Furthermore, due to its low melting temperatures, minimal odor, and easy handling, PLA is favored in 3D printing. It exhibits minimal warping during printing and is suitable for detailed prints. Coming up next, I want to share the industrial manufacturing process for PLA. So, derived from biomass, PLA industrial production includes three main steps, including fermentation, separation, and polymerization. Now, we'll take a closer look into this illustration. So, firstly, lactic acid is produced via fermentation from cornstarch. Then, lactic acid would go through a condensation process to remove water to form low molecular weight PLA. Next, we'll go to a step called depolymerization process to synthesize the lactate monomer. Since lactide is a chiral molecule, it could be a mixture of two enantiomers, including L-lactide and D-lactide with a mesolactide. Finally, this lactide would go through the ring opening polymerization process with stannous octanoate, which is a catalyst in this case. And at the end, would have high molecular weight PLA as our final product. The advantage of PLA production comparing to other petroleum-based polymers is the decrease of CO2 emission and a lower environmental impact due to the use of renewable sources. And this is my 3D model for the lactic acid monomer on Tinkercad with the chemical formula of C3H6O3. Now, I want to talk about the application of PLA. So PLA is used in a wide range of application. The first thing I want to discuss about is packaging, especially food packaging. Because of its great biocompatibility, good physical properties, PLA is widely utilized in manufacturing of bottles, jars, and containers, as well as in fresh food packaging solution. PLA could also be used to manufacture single-use products, including lids, cutlery sets, and straws. Additionally, fully biodegradable PLA gloves or bags could mitigate the accumulation of plastic in our environment. Especially in disposable products and packaging materials, its biodegradability contributes to environmental sustainability. For automotive industry, PLA biofiber composites are utilized to make various automotive components, such as dashboards, door panels, pocket trays, or headliners. In medical application, PLA is used in bone tissue engineering, the treatment of blood vessels, and skin regeneration. PLA-based particles are also commonly used as control drug delivery system of therapeutic molecules. So now I want to discuss about some challenges and disadvantages of this material. So while PLA is an eco-friendly biomaterial with exceptional properties, it also has many drawbacks in certain applications. One of the biggest disadvantages of this material is that lactic acid is derived from corn, which is a main food product. Therefore, new technologies should be applied in order to produce lactic acid by using glucose derived from plant biomass. And although PLA is a biodegradable polyester, but it's only degrade under specific conditions, and in natural environment, it takes at least 80 years for PLA decomposition. As a result, PLA needs to be broken down via natural biological processes, such as the action of bacteria or the presence of specific enzymes. And for commercial application, in packaging, for example, due to its low flexibility and poor crystallization behavior, PLA is mixed with other biodegradable plastics to enhance its flexibility. So, in conclusion, PLA is a promising bio-based and biodegradable materials replacing the traditional plastics. They have a lot of advantages in their low cost, renewability, biocompatibility, and transparency, so that it can apply in many applications in different fields. However, they also have a lot of disadvantages, such as low heat stability, the limitation in some mechanical properties. Therefore, further efforts and technology need to be developed to overcome these challenges in order to protect the environment. So that's it. Thank you so much for listening.